obviously this must be separable, right? But as we begin to accumulate more techniques, you're going to have to be able to distinguish one type of equation from another. Unfortunately, being separable isn't something that you can necessarily identify just by glancing at the equation. Okay. So if you're unsure, then what you should do in order to check if it's separable is solve for the derivative and then back to the right-hand side. Okay? If the right-hand side cannot be factored, or if some factors contain occurrences of both x and y, then that means it's not separable. So let's solve for the derivative. And attempt to factor.
Take a y right out of
Common
it.
factor of y, so it's a good start. So we have factored, but this right now doesn't mean that it's separable, right? The first factor only contains y, but the second factor contains both x and y. Can this be factored further? How? Any ideas?
X
Yes.
X minus one, y minus one.
X minus one. Yeah, I think that's right. That's a pretty good guess. What were you going to say?
I mean, it leads to that, but you like do the group the first two.
So if you have 4 terms, one trick that you might attempt is to factor by grouping. Do you remember this? So the way that this technique works is you group the first 2 terms, you group the last 2 terms, factor the common factor from them. So okay, so let's group the first 2 terms, x, y minus x. Okay, with this technique, if the center sign is negative, you always want to group it with the second group and change it to plus. Okay, so plus minus y plus 1. Okay, and then you hope that after factoring the greatest common factor from these 2 groups, what's left is the second, making it a greatest common factor as well. So here the common factor is x. Okay, so we would like this to also be y minus 1. So in order for it to match, we could factor minus 1 from this, right? So with me? So now we have 2 terms, and y minus 1 represents the common factor between these 2. Okay, so we have y, and then if we factor y minus 1 from this, that leaves us with x minus 1. Okay, now it's clearly separable. We have 3 factors. This only contains y, only contains y, only contains x. So it's separable. Okay, so let's write it in differentiation. So dy dx equals y times y minus 1 times x minus 1. So if I multiply by dx and divide by y times y minus 1, we have this. With me? Good. So now we need to integrate. The the right-hand side is easy, the left-hand side, not so much. Anyone know how to integrate this?
Brain scratching out the integration by parts.
I guess you could try integration by parts. It's not going to work.
Would you multiply it out?
You could try that, but that's not going to do it.
Substitution,
Substitute for what?
manipulate the, u equals y minus one,
U equals y minus one, and then
and then,
du would be dy, and then y would be u plus one. So that would
That's right,
transform it
and then-
into basically the same problem. Instead of y times y minus one, you'd have u times u plus one, which is essentially the same problem. No guesses? You want me to
I
just
mean,
tell you?
If you just
Yeah.
have whites,
Can you convert that to get rid of y to the negative two minus y to the negative one?
So you multiplied, and then you're saying that the denominator is y squared minus y. You can't write that as y to the minus two minus y to the minus one. Y to the minus two minus y to the minus one is one over y squared minus one over y, and you can't split sums and differences in the denominator. So the answer is partial fraction decomposition. You remember this? We'll be using this several times. There will be a couple of integrals that you run into that you'll have to rely on some techniques that you learned in Calc 2. So I think maybe we'll see a few trig substitutions, but partial fraction decomposition and integration by parts are going to be used pretty frequently. So do you remember what that means? Now that I've told you the answer. So this is a technique that you use whenever you're trying to integrate a rational expression, that's a polynomial divided by polynomial, where the denominator factors. But almost always, unless the denominator factors but u substitution also works, usually the answer is partial fraction decomposition. You remember?
And
Yes.
then also, the numerator has to be of a lower degree.
And if it's not, then you divide first. All right. Remember?
I do not.
So each factor is going to give you a partial fraction. Okay, so let's rewrite this first. Okay, so one over y times y minus one. Okay, so each factor, so we have two factors, y and y minus one, this is going to give us a partial fraction. So the denominator of the first is y, the denominator of the second, y minus one. Do you remember what goes in the numerator? So if the denominator is linear, power one, numerator is constant. Okay, if the denominator is quadratic, numerator is linear. So the degree of the denominator is always one more than the degree of the numerator. So here, this is just constant, and then constant. Now what? Now we need to determine A and B.
divide y minus.
Yeah, so multiply by the common denominator, so if we multiply by y times y minus one, left-hand side is one. Right-hand side would be a times y minus one plus b times y. Now what?
Take the coefficients of the,
Yeah, there are actually two strategies that you can use. Let me show you one place. Okay. So this is supposed to be true for every single y, right? So if I expand this, one equals a times y minus a plus b times y. And let me write that this way. That's a plus b times y minus a. Okay, so this is supposed to be true for every single y. Right? So what does that mean? That means that the coefficient of the linear term has to match the coefficient of the linear term on the left-hand side. But there is no linear term, so that coefficient must be 0. Agree? Okay. And whatever this constant is, has to match this constant. So let me just write it here for purposes of demonstration, so you can think of this as 0y plus 1. So this linear term has to match this linear term, this constant has to match this constant. Okay, so what's the conclusion? 0 times y is equal to a plus b times y for every single y. In other words, 0 is equal to a plus b. Okay, and then minus a is equal to 1. Okay, so this tells us a. So a is equal to minus 1. Now that we know a, we can find b with substitution. Okay. And minus 1 plus b is equal to 0, which makes b equal to 1. Coming back to you. There's actually an easier strategy that works, especially when every factor is distinct. So not like y times y minus 1 to the second power. So if every factor is distinct, let's start back from here. So we know that this is supposed to be true for every single y, which means that it's true for any particular y. So if you want, you can feel free to substitute any value of y that you would like. See what I'm getting at? What would be a nice value of y to substitute?
1.
If I substitute y equals 1, then that's going to remove this unknown. So rather than doing this, 90% of the time I'm going to get at these constants using particular values of y. So if you choose a value of y that zeroes out one of the terms, you can get them one at a time. So if you choose y equals 1, then we know that 1 equals a times 0 plus b times 1. So b equals 1 like we got here. And what else? To remove this, y equals 0, so we choose y equals 0. And then 1 equals a times -1 plus b times 0. Negative a equals 1, a equals minus 1.
It belongs to the school now.
Remember this now?
Yeah.
So let's go back to this equation. So instead of this expression, now we know that this is what? A minus 1 over y plus 1 over y plus 1 dy is equal to integral of x minus 1 dx. Okay, so let's integrate, omit the absolute value. So what is this? Negative natural log y, right? What is this? So it's natural log of y plus 1. Why is that?
Natural log.
What if it were this? Is that natural log y squared plus 1?
No.
Why not? What are you doing to say, so I agree that it's this, but tell me why. What am I really doing to write this? Yes?
If you were to differentiate natural log of y squared plus 1, it would be
something
Two
different.
natural log, y.
Yeah, so why can we write this? What we're really using is substitution. I'm saying let u equals y plus one, du equals dy, right? So if the denominator is linear, then you can feel free to do this, right? You need to be careful if this were like 2y plus one, then you pick up a factor of 1/2, right? If it's not linear, like y squared plus one, you need to use something entirely different, okay? So be careful with that. All right, so we have that, and then equals, this is half x squared minus x plus c. Okay, and if it's not apparent that you can solve for y, feel free to leave it like this. So after you've used the technique, no simplification is necessary. Okay. Any questions about this?